Okay, so welcome to today's class. We have another question on the board. We have that 2 raised to the power x plus x is equal to 11. And we're asked to find for the value of x. Let's try to solve this question together. So we're going to start by rewriting this equation. And then we're going to move this x value over to this side so that we have this 2 raised to the power x standing on one side, and then we have 11 minus x on this side. So now we have that 2 raised to the power x is equal to 11 minus x. Now, if we divide through by 2 raised to the power x, we have 1. Therefore, we have 11 minus x over 2 raised to the power x equals 1. Now we can rewrite this and bring this 2 raised to the power x over to the top. And when that happens, this x at the power gains a negative sign. Okay, so now we have that 11 minus x, 2 raised to the power minus x is equal to 1. Now, to be able to solve this value of x, we need to employ the Lambert's rule. And the Lambert's rule states that w a e raised to the power a is equal to a. This is the rule. So we're going to try to rewrite this left-hand side in this format so that we can apply the Lambert's rule and then get this a value or get the x value, whatever the value is. Now, here we can see we have 11 minus x, 2. It's looking like it. And then we have minus x. So to make this here look like the power, we need to add 11 to this power to make it 11 minus x. And to do that, all we need to do is multiply by 2 raised to the power 11. And remember, whatever you do to the left hand side, you need to do to the right hand side as well. So this becomes 1 times 2 raised to the power 11. So now when we rewrite this, it becomes 11 minus x, 2 raised to the power 11 minus x equals 2 raised to the power 11. Now this is very close. We have the same values there and there, but we have 2 instead of e. The equation says e, not 2. So we can rewrite this. There's a formula that states that e raised to the power ln x is equal to x. So if you say e raised to the power ln 5, that value is equal to 5. Now, that's just an example. So for us to have our e at this place, at this position, we need to employ this rule here. And 2 means that what we're going to have here would be e raised to the power ln 2, because e raised to the power ln 2 will be equal to 2. So let's replace this 2 with e raised to the power ln 2. So this becomes 11 minus x, e raised to the power ln 2, 11 minus x equals 2 raised to the power 11. Now, we notice that we've introduced a something new here, ln 2, which we do not have on this end. So that's what's preventing this base and this power from looking the same. So what we do is introduce ln 2 at this base so that it looks the same as the power, and then we can use this. And then remember, whatever you do to the left hand side, you do to the right hand side. So let's carry on this side. So we have that 11 minus x, e raised to the power ln 2, 11 minus x is equal to 2 raised to the power 11. So if we multiply both sides by ln 2, we have ln 2, 11 minus x, e raised to the power ln 2, 11 minus x equals 2 raised to the power 11 ln 2. Now, okay, so now this is looking like what we have here, because we're having our formula we have our formula to be this, and if you apply the Lambert's rule to it, it becomes this, because we're trying to get this value of x, right? So this now becomes, applying the Lambert's rule, becomes ln 2 11 minus x e raised to the power ln 2 11 minus x equals w 2 raised to the power 11 ln 2. Okay, so from the rule, this becomes ln 2 11 minus x. Now we can't just, write anything on this side, because this, what we have in this bracket, in this parenthesis here, is not looking like what we have here. So let's try to rewrite what we have on this side to look like, what we have here. Okay, so now we know that we can rewrite 2 raised to the power 11 using indices to become 2 raised to the power 3, 2 raised to the power 8. From a law of indices, this becomes 2 raised to the power 3 plus 8, and that would be 2 raised to the power 11. Same thing, okay? So we're going to rewrite 2 raised to the power 11 as 2 raised to the power 3 dot 2 raised to the power 8 ln 2. Okay? Now this is what we have. So this becomes ln 2 11 minus x w 2 raised to the power 3, 2 times 2 times 2, that's 8 dot 2 raised to the power 8 ln 2. We can rewrite this as well to become 8 ln 2 2 raised to the power 8. Okay, now we have this standalone 2 raised to the power 8. Just like we mentioned earlier, e raised to the power ln x is equal to x. Therefore, e raised to the power 2 raised to the power 8 is also 2 raised to the power 8. Okay, so let's rewrite that way with the ln. So this becomes w 8 ln 2 e raised to the power ln of 2 8. Now this 8 can come over here and become 8 ln 2. So that becomes ln 2 11 minus x w 8 ln 2 e raised to the power 8 ln 2. I hope there is no confusion here, okay? Because we're trying to go step by step by step, so it's easy to understand, okay? Just gonna wipe off this so I can continue on this side. Now, what we have here is ln 2 11 minus x equals w, the Lambert's formula, 8 ln 2 e raised to the power 8 ln 2. Okay, now we have same thing on this side and also on the base and also on the power. So this Lambert rule applies, and this becomes ln 2, 11 minus x equals 8 ln 2. So now this is in a very simplified format. So now to be able to find the value of x, we need to get rid of ln 2 on the side. So we divide through by ln 2. That cancels out as 1. That cancels out as 1 as well. They cancel out. So we have 11 minus x equals 8. And if we move this to the side, 8 comes over here, becomes minus 8. X goes over to this side and becomes positive x. So we have 11 minus 8 equals x, or x equals 11 minus 8, same thing. X now is equal to 3. This is our answer. Now to verify this, this is our equation. So if we plug in the value of x, which is 3, in there, we have 2 raised to the power 3 plus 3. We're trying to find out if that is equal to 11. 2 raised to the power 3 is 2 times 2 times 2, which is what? 8. Okay. That is 8 plus 3. Now we have that 11 coming over here. 8 plus 3 is 11, which is equal to 11. Therefore, our left-hand side is equal to our right-hand side. That means our value for x, which is 3, is correct. So, if you've learned something new today, make sure to like this video. If you like what I'm doing, subscribe. Make sure to share this video so somebody else can learn something new as well. I'll see you on the next one.